So the CCAR REU is an interesting project because it sort of has two focuses. One of the focuses is the science, and so we've got a bunch of researchers that are doing climate change related stuff or air quality related stuff. And the other focus that we came up with was trying to give research opportunities to people that might not have had them.
Students that come into these kind of programs don't have much research experience. That's kind of the point. So we're getting them a taste of research. They can kind of get a sense of whether research is something that they clear that they might want to pursue or not.
During the CCAR RCU program, I'm looking at urban air pollution in Portland, specifically 122nd Division. We have like 20 sensors laid out in the houses near the intersection, and we're seeing if there's spatial and temporal trends and if there's a difference between each house.
So for the REU program, I am researching the meteorological drivers behind the January 2017 snowstorm in Portland. It was the biggest snowstorm we've had in 20 years, and it wasn't very predicted. So I'm looking at what large-scale features led to this small-scale storm.
My research is understanding how data sets of methane concentration affects our understanding of methane source categories. So previously, my mentor, Dr. Butenhoff, implemented an inversion model that allows us to take observation from the field, the chemical transport model, and a priori data emission sets, and use that to approximate parameters of methane source categories.
I am bringing a Picaro cavity ring-down spectrometer up to a level of precision that's acceptable for testing air samples from Cape Mears, Oregon, from years of 1977 to 1998.
I'm looking at urban air quality and traffic-related pollutants and how certain traffic variables can change variation in criteria air pollutants like ozone, particulate matter, nitric oxide, carbon monoxide, those kind of pollutants.
There have been a lot of things I would say that I didn't expect to learn from this program, such as, the bureaucratic workings behind doing research. I've also learned a lot about opportunities for trying to fund my own research in the future.
Well, I applied for the program because I felt it was going to be a great opportunity to kind of get a look into what research really is at a university kind of level.
It's an average day. I come in, I've got soil samples in evacuated flasks going on the shaker table to keep them at a consistent slurry, and I will extract gas samples from the headspace in those and run them through the gas chromatograph for methane content.
One thing that's been really useful, I would say, that I've learned is how to write a good abstract. My mentor recommended a 8-step process of 8 things you should put in your abstract, which is really helpful when I was writing it out.
If I haven't done this program, I would probably have never learned how to code or learn how to do data analysis or make maps or any of this.
Well, what I've taken away from this program is that you have to learn to adapt to a lot of styles and become independent. And sometimes it's hard and sometimes you feel out of place, but it's very rewarding at the end.
So far, the main thing I've learned is computer programming and coding. I think it's a really valuable tool no matter where you're going.
So predominantly I learned from the program what one of the mentors described as science in the making, and that would be the aspects of documentation and experimental setup that goes into research. Previously in class I would just learn facts about science rather than how to make and solve problems in it.